These are the stacks of steel that will become the Damascus for the gun barrel. These stacks are each 13 alternating layers of two different steels. They will be forge welded together into solid billets. Forge welding the two stacks of steel together using a 50-pound Little Giant trip hammer.
Two billets have been welded together now. I've cut them in two, restacked them, tack welded them back together, so they're now 26 layers. I'll weld these together and draw them out into bar stock.
Using the trip hammer to set the welds on the restacked billets. Continuing the drawing out of the billets using a hydraulic forging press. The Damascus billets have been drawn out into 1/2 inch square rods. They are now ready for twisting. The rods are twisted hot while still in the forge. One end of the rod is held in a vise mounted on the forge. The other end of the rod is twisted using a cordless drill. The rods have been twisted along their full length. One rod is twisted to the right, the other to the left. These rods will be welded to each other to create the riband. Forge welding the rods together begins at one end of the rods. They are being forge welded together here in the hydraulic forging press. Continuing the welding near the center of the rods. Here are the two Damascus rods. They've been forge welded together to create the ribbon that will become the gun barrel. They have been drawn out into a rod that is 5/8 of an inch wide by a 1/2 inch thick. Winding the ribbon into a coil begins. The end of the ribbon is cooled in water to make it rigid so it will not bend. The cooled end is placed behind a stop block on the mandrel assembly and the first turn is started. The ribbon is heated section by section and it's wound around the mandrel a turn or two at a time. The winding process often tightens a ribbon coil around the mandrel so snugly it's necessary to use a hammer to drive the tapered mandrel out of the coil. And finally, the full length of the ribbon is wound into a coil. The end of the ribbon that was cooled at the start of the winding process is forged down around the mandrel to complete the other end of the coil. Additional forging of the coil with a hammer is necessary to get all the turns of the ribbon to lay down tightly against the mandrel. Here is the ribbon coil. It's had the forge scale cleaned off of it by soaking it in sodium bisulfate and wire brushing. The ribbon coil has about a 5/8 inch diameter hole down the bore and is about 1 5/8 inches in diameter. The ribbon coil is ready to be forge welded into a solid tube. I have a special forge that I built for welding gun barrels. With this forge, I can localize the welding heat along the length of the barrel tube. The forge welding process begins by welding the tube while it is inside the forge. The tube is lifted by a special mandrel and jump welded against an adjustable plate behind the forge. The jump welding of the tube is continued by heavier forging on an anvil with a hand hammer. Very heavy forging is required to close the welds between the turns of the ribbon. During the heavy forging, the coil is placed around a mandrel that is mounted vertically on the anvil. Once the coil is sufficiently jump welded, it's now time to start forging it around the outside in the trip hammer to reduce the bore diameter. This begins by jump welding it one more time to secure the welds, placing a mandrel inside of it, and then forging in the trip hammer. The process continues by repeated forgings, each time sliding the tube a little bit farther down the taper mandrel. The outside forging closes it down on the mandrel and gradually reduces the diameter of the bore hole. The forging continues until the tube is all the way at the end of the mandrel. At this point, the bore is being forged down to about 3/8 of an inch. All of this forging is done with the tube placed crosswise in the dies. This is where the hammer has the most effect and the most power to reduce the diameter of the barrel. The final step in the barrel forging process is to forge the barrel lengthwise in the hammer dies. This serves to straighten the barrel as much as possible. And finally the barrel tube right after it is cooled from the forging process. The outside of the tube is about 1 3/8 inches in diameter, and it has about a 3/8 of an inch bore in it. Here is the barrel tube after it was cleaned in sodium bisulfate and wire brushed. The tube is ready to begin the machining process, where it will be bored to its intended caliber and the outside turned to final dimensions. Here is the barrel after all of the machining has been completed. A light etch has been done on the barrel to display the Damascus pattern. The barrel has been finished out to 50 caliber bore. The breech end of the barrel has been drilled and tapped for a breech plug. The barrel will be mounted on a breeching system and test fired. The barrel is being loaded with 40 grains of 3F black powder and a 490 round ball with a 15 thousandths patch. The barrel at this point is mounted on the breeching system. It will be fired on this breeching system using cannon fuse to set it off.